Wait a minute. If black holes are real and we can literally photograph their shadows, what does it actually mean when people talk about white holes as their opposites? Are we dealing with hidden cosmic monsters out there? Or just a strange ghost that lives only inside Einstein's equations? In general relativity, a black hole is a region where an event horizon lets matter and light fall in but never escape. And if you take that same solution and run time backwards, you get a mirror object where matter and light can pour out but nothing can ever fall in. A one-way exit instead of a one-way entrance. And that time-reversed creature is what physicists call a white hole, even though from far away its gravity would look almost identical to a black hole of the same mass, still bending light and tugging on stars so well that you would only notice the difference at the very edge of the horizon. The problem is that the universe knows how to make black holes from collapsing massive stars and smashing neutron stars. But to make a white hole, you would need matter arranged in an absurdly fine-tuned way that just happens to explode perfectly when time moves forward, like a shattered glass spontaneously leaping off the floor and rebuilding itself on the table. The equations may allow the movie in reverse, yet the odds of nature actually filming that scene are essentially zero. Even if you somehow created one, a white hole dropped into our messy universe would be bathed in background radiation and stray particles. And calculations show that any tiny bit of stuff trying to fall in tends to wreck the clean, only-out behavior, pushing the solution towards something that behaves more like a normal black hole or just distorted space-time. So long-lived white holes are incredibly unlikely, not because the math forbids them, but because reality refuses to keep them intact. On top of that, you have the arrow of time. Black holes fit nicely into thermodynamics. They have entropy, they radiate. They evolve in a way that respects the idea that disorder grows, while pure white holes look like systems where entropy is effectively running backwards, as if the universe carved out a little pocket where broken eggs reassemble and smoke returns to the match. And that clashes with almost everything we see about how time actually works on every other scale. Of course, theorists still like to play at the edges. Some quantum gravity ideas suggest that the interior of a black hole might bounce instead of ending in a true singularity and eventually reappear as a tiny white hole that drips information back into the universe. And people sometimes say the Big Bang has a kind of white hole flavor, with matter and space-time emerging from a boundary we cannot see beyond. But for now, those ideas live on paper and in simulations, not in telescopes. So in the universe we can actually observe, the scoreboard is simple. We have strong evidence for black holes in X-rays, in gravitational waves, in direct images of their shadows, and we have zero confirmed sightings of white holes as real objects. Which means that when someone says white holes are the opposites of black holes, the honest answer is that they are opposites inside the mathematics of general relativity. But so far, the cosmos seems to have chosen only one half of that elegant pair, leaving white holes as beautiful ghosts in the equations, while the real night sky is ruled by the deep, dark wells of gravity we have seen, and are only just beginning to understand.